All right, welcome back, everyone. We're doing Unit 5, Lesson 2, Part 1. So here we're going to prove of cos x minus y. So just so you are aware, cos of x minus y is not equal to cos x minus cos y. That's just not the case. So please, please, please don't ever do that. You cannot do that. So if that's the case, then so what does it equal? Well, we're going to look at this diagram here. Let's say we have a diagram. We have, our unit circle. We have an angle that's like this. Angle B, and then we have angle A like this. I'm going to color code it so you guys can see a little bit better. So here, angle B is in black, and angle can be in red, angle A. Okay. And in case you're wondering what's going on, remember this is just your kind of 360 Cartesian plane. You're drawing your terminal arm. You have your 0, 90, 180, 270, and then 360. And it's just drawing a terminal arm. One terminal arm is here and the other one is here. That's what's going on, A and B. And remember, this is the angle B, and then A is from here to here, and that's angle A. And we're going to connect these two points here. And that's going to give us a value of C. We're going to call this C, this line that's going from here to here. That's C. So that's in blue in this diagram. If you are unaware, your X and Y values, when you have a unit circle are just your cos of your angle and your sine of your angle. So your X value is cos A and your Y value is sine A for this point here. For the point that is here in black, your X value is cos B and your Y value is sine B. Remember, for a unit circle, if you forgot, the hypotenuse is 1, right? So we have our X value, meaning the horizontal distance. We have our Y value, which is the horizontal distance, and we have R. And R in this case is 1 because it's a unit circle, so the radius is 1. And if this is our angle, theta, we know cos theta is equal to, this is a right angle triangle, adjacent or hypotenuse, which is 1. So cos theta is basically just equal to x. And similarly, sine theta is equal to y over 1, or just y, because anything divided by 1 is. So this is why we write cos A and sine A and cos B and sine B, because these are our x and y values. So once we have these points, we can use the distance formula to solve for C. Remember, the distance is from this point to this point. That is C. So we're going to use that right now. Let's plug in these values. Let's do that right now. So x2, we'll label x2 as your A value. Our A value can be our x2 value. So this is going to be x2, y2, and 1 and 1. So we're going to have c squared is equal to x2, which is cos A, minus cos B. Remember, these are just your x values, squared, plus sine A minus sine B squared. And this square root sign, what I've done is I've actually taken it over to the other side of the equal sign. So instead of being c equals square root of all this, I just took the square root to this side, and it's now c squared. So c squared is equal to this distance formula, and we can simplify and expand this distance formula. So c squared is equal to, this is a minus b squared, right? So cos squared A minus 2 cos A cos B plus cos squared B. So that's the first bracket that's been expanded. And if you don't believe me, you can just multiply it out yourself. And then sine minus sine A minus sine B all squared is basically the same thing. So it's going to be plus sine squared A minus 2 sine A sine B. And then I ran out of room, but the last bit of it is plus sine B sine squared B. There you go. Once we have this, something that you should know is cos squared A plus sine squared A is equal to 1. Remember, sine squared plus cos squared is equal to 1. That's the trig identity. So if I have cos squared A plus sine squared A, if I add them together, it's basically just 1. So that's going to be 1 minus 2 cos A cos B. And now here we have plus cos squared B and sine squared B. Once again, same thing. Same angle. Cos squared plus sine squared. That's also going to be equal to 1. So that's going to be plus 1. And so we're got rid of this, got rid of this. And we're left with minus 2 sine A sine B. And this is all equal to c squared. And the c squared is equal to 2 minus 2 cos A cos B minus 2 sine A sine B. So this is going to be one equation here. This is one equation. So we use the distance formula to solve for an expression that equates for our c value, or c squared value. Another thing that we can use is cosine law. This is a triangle. And this is an angle here. This angle here in blue is A minus B. Because angle A, if you can see, goes all the way from the x-axis to the red terminal arm, and angle B goes all the way from the x-axis to the black terminal arm. And then the space between the black and red terminal arms is angle A minus B. Because, yeah, that's how it works. So that is equal to, that's the angle inside our triangle here, and opposite side C. So if we're going to use cosine law, we're going to have c squared is equal to 1 squared plus 1 squared. How did we get 1? Well, remember, this is a unit circle, and the radius is 1. So we know that this is 1, this is 1. We don't know what c is. That's not 1, because that's not the radius. So c squared is equal to 1 squared plus 1 squared minus 2 a times b, which is 1 and 1, cos A minus B, because that's the angle that we have. And in this case, c squared is equal to 2 minus 2 cos A minus B. I'm going to write that down now. So that is from the cosine formula. And the other equation was from our distance formula. So in this case, c squared is equal to, what was it? 2 minus 2 cos A minus B. Since both of these equations are solving for the exact same thing, essentially, for C, they're solving for C, we know that we can just equate them, because c squared is equal to this, c squared is equal to that. So now we're going to make these two equations equal. So we're going to have 2 minus 2 cos, sorry, I should write it a little bit neater. Here, I'll write slower. This is our first equation, and that's equal to our second equation, which is 2 minus 2 cos bracket A minus B. And remember, we're trying to solve for cos x minus y, or in this case, a minus b. So we are going to isolate for this term. We want this on one side and we want everything else on the other side. The first thing I'm going to do is I realize, well, hey, there's a 2 here and there's a 2 here. That can just cancel out. I can just subtract 2 from both sides. So they'll cancel out. Next thing I'm going to do is I'm going to divide everything by -2. This -2 will cancel out. This -2 will cancel out. This -2 will cancel out with all of these. And we're left with now cos A. Sorry, there's a negative there. Minus. Oh, sorry. The negative sign is gone actually because we've divided by negative and negative. So negative sign is gone. So it's cos A cos B plus sine A sine B is equal to cos A minus B. And there we've solved now the initial question of what is cos x minus y? Well, cos x minus y, in this case x being A and y being B, is equal to cos A cos B plus sine A sine B. Or if you really want to use x and y's, obviously just change it. There you go. There we have it. So that's a proof for a compound angle formula. Not too bad, right? Another way that we can do this is as follows. Let's see. Okay, prove cos x minus y is equal to cos x cos y plus sin x sin y. Same thing that I just said, but we're going to use trig identities now. We know that cos, left-hand side, right-hand side, obviously, first. We know cos x minus y is the same thing as cos bracket x plus negative y. Right? And what we're going to do is we're going to write it in terms of... Sorry, I forgot to mention something before. I forgot to give you this piece of information. That is this one here. Oh, sorry. Where did it go? All right, so here we have. This is identity that you can use to help us solve for this. Actually, it's funny, I already solved for this the other way, but we're going to use this now. All right. So, assuming, you know, I didn't do it the way I did it initially, and we're just going to use this trig identity to solve for it. So if I have cos x plus y is equal to cos x times cos y minus sin x sin y, this, whenever you're subtracting something, you can rewrite it as an addition, right? It's the same thing as adding, like if I'm doing 5 minus 1, the same thing as 5 plus negative 1. So in this case, cos x plus negative y, we're going to just rearrange it and use these values here. So that's going to be cos x, and cos negative y, minus sin x and sine of negative y. And hopefully you remember from the even odd functions that if I have an even function, if I substitute a negative value in, it's equivalent to the positive value. So here's just cos x cos y. The negative y doesn't change anything. But if I have an odd function, then what that negative sign does is multiplies the function by -1. So this becomes plus sin x sin y, and that is the proof, I think. Yeah, that's it, done. left hand side is equal